Organic chemistry began as the chemistry of life, thought to be separate from lab chemistry. It evolved into the study of carbon compounds, especially those found in coal. But now, it's so much more than that. It's the chemistry of carbon and its compounds, found in living things and their products. Carbon is everywhere, connecting life and laboratory in fascinating ways. The most abundant organic compounds are found in living things and those formed from the remains of the past. In ancient times, we knew about organic compounds mainly through essential oils distilled from plants. Alkaloids were extracted from crushed plants using acid, revealing nature's hidden treasures. Take menthol, for example. It's a flavoring compound from the essential oil of spearmint. And then there's cisjasmone, a beautiful perfume distilled from jasmine flowers. These compounds connect us to nature, showcasing the magic of organic chemistry. Natural products have been our allies in healing for centuries. In the 16th century, one remedy rose to fame: quinine from the cinchona tree. This bark was a lifesaver for fevers, especially malaria. The Jesuits called it Jesuit's bark, unaware of its molecular magic. Today, we know quinine's structure and its impact on modern medicine. Its design has inspired new drugs that fight malaria even better. Nature's wisdom continues to guide our fight against disease. In the 19th century, a revolutionary idea emerged in surgery. Lister used phenol as an antiseptic. This sparked a quest for synthetic compounds, moving beyond nature's offerings. Enter William Perkin, an 18-year-old chemist in 1856 who accidentally created mauveine while trying to make quinine. This mauve residue changed the game for dyeing cloth, launching the synthetic dyestuffs industry. And let's not forget Bismarck brown, a classic dye still in use today, thanks to early German innovations. The world of chemistry was forever transformed, paving the way for vibrant colors in our lives. Among the 16 million molecules created, there's a world of diversity. What do they look like? Crystalline solids, oils, waxes, and more. Familiar examples include sugar, those hard white crystals from plants, and petrol, a flammable mix of hydrocarbons, colorless and volatile. Isooctane, a key player, even gives its name to the octane rating of petrol. So, next time you see these substances, remember their amazing properties.